Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. I welcome you all into my today lecture. Today is our lecture number 31, Unit 8, and it is the last portion of the unit thermal properties of matter. Here, we will solve questions and numericals as per your demand also. So let us start with the question part first. Here you see that they are asking you that encircle the correct answer from the given choice. Water freezes at option A 0. Option A is, the option A is 0 degree Fahrenheit, 32. Option B 32 degree Fahrenheit. Option C minus 273 Kelvin, and option D 0 Kelvin. So the correct option is option B. The correct option is what? The correct option is the option B is the correct option. Why? Because you know that water freezes at 0 degrees centigrade, and when you convert 0 degrees centigrade on the Fahrenheit scale, it will be 32, not 0, nor 0 Kelvin, nor minus 273 Kelvin. Why? Because it is 0 Kelvin is the absolute temperature, minus 273 degrees centigrade. So the others are not correct. The normal body temperature is 37 degrees centigrade. There is no rocket science in it. You already know it. Mercury is used in the thermometric material because it has uniform thermal expansion, low freezing point, small heat capacity, all of the above properties. Of course, all of the above properties. Uniform thermal expansion is correct, low freezing point is correct, small heat capacity is also correct. Which of the following material has large specific heat? Then of course I told you when I was teaching the specific heat of a substance, then I told you that water has the largest specific heat capacity. It is one of being the universal solvent. All of its properties are very unique, and so does its specific heat also. So it is very large. uh, right. So which of the following material has large value of temperature coefficient of linear expansion? It's aluminum, I think. So definitely these are statistical things for which you need to remember the values, and sometimes it is very difficult, but what we can say if it is the part of your exam. So you just look whether I'm right or not. You see in the table, I guess it is aluminum, but even for more surety, I will tell you that there is a table on the left margin on your book, okay, where there is the coefficient of various substances. Sorry, in the right margin, yes, the left. So you see there, and look whether it is aluminum, gold, brass, or steel. Okay, I don't remember it. Now the next one is what will be the value of beta for a solid for which alpha has a value of this. So if you remember, I told you that beta always equal 3 times alpha. So any value which is the multiple of 3 here will be the correct, and mostly that is of course option B. So it is like this. Now the next one is a large water reservoir keeps the temperature of the nearby land moderate due to option A, low temperature of water, low specific heat of water, less absorption of heat, large specific heat of water. So of course it is the large specific heat of water. If you remember, I told you when I was teaching to you this topic that the area near the seashore and the lakes are always, the areas are always mild and pleasant. And then I told you that it is because of the reason of the high specific heat of water and the process of convection. So one is this. The last one, which of the following affects evaporation, temperature, surface area of the liquid, wind, all of the above? So when I was teaching to you the factor affecting the evaporation, so definitely these three was were there. So all of the above is the correct option. Now let us move on to the numerical part of the exercise. Here you see that look, the first question is that the temperature of the first problem is the temperature of the water in a beaker is 50 degrees centigrade. What is its value in Fahrenheit scale? So here the temperature in centigrade is given. TC is this one. You need to change it into temperature in Fahrenheit. Okay, so it is the TK, temperature in Fahrenheit is required. So look, the for the conversion, so the temperature in Fahrenheit, if you remember, I even derived this to you that it is 1.8 TC plus 32. So use this and you will come across the solution. Okay, this will be the answer. And the next one is the normal human body temperature is 98.6 degree Fahrenheit. Convert it on the Celsius scale. So here temperature in Kelvin, temperature in Fahrenheit is given. You need to express it in the Kelvin scale, the temperature in Kelvin, and you need to express this in the Celsius scale also. So look, this is so easy here. From even you do that the temperature in Fahrenheit is given, 32 is plus there, do it minus, and then you see it is centigrade scale is multiplied by 1.8, so there you divide this by 1.8, and that will be the temperature in centigrade. So once you get the temperature in centigrade, then add 273 here and you will get the answer for the change into the Kelvin. So these are very easy. Okay, now the next one, calculate the increase in the length of the aluminum bar. 2 meter long. So here the length of the aluminum bar, that is the original length, L naught is given. When it is heated from 0 degree centigrade, so this is your temperature T1 to 20 degree centigrade. So this is your temperature T2. In thermal coefficient of expansion, this is alpha. It is also given. Alpha is this. So they ask you to find the delta L, that what is this change in length. So of course, if you remember, I told you that the change in length equals the alpha times the L naught into delta T. Now, what is delta T? First, you need to change it into what? Into the Kelvin. So it will be 273 Kelvin. There it will be 20 plus 273. So it will be 293 Kelvin. And then you find delta T is T2 minus T1, which is 20 Kelvin. Now, one important thing which I want to tell you, that if you want to find out the difference in Kelvin, then do one simple thing. And what is that one simple? Just you look the difference in centigrade and write delta T and instantly write 20, but not centigrade Kelvin. This is particularly best for MCQs. Best for MCQs where your time is important, right? So don't do there that T1 is equal to 0 plus 273, T2 is equal to 20 plus 273, 293 Kelvin. So this is a very long process for your MCQs. Just look the difference and write the Kelvin, because both ways it is the same. A balloon contains one next numerical. Balloon contains 1.2 meter cube of air at 15 degrees centigrade. So here the volume of the air is given, and that I will mark as this volume is original volume V naught, and it contains at 15 degrees centigrade. So this is your T1. Find the volume at 40 degrees centigrade. So this is your T2. Okay, the thermal coefficient of volume expansion of the air, so of course beta is given. So this is as eating ice cream, right? So you can do it in the same way here. The change in volume will be equal to beta times L V naught into delta T. Here the delta T will be the difference in temperature in Kelvin. Why? Because it's the unit consistency checking is extremely important. So 40 minus 15, 25, but not 25 degrees centigrade, 25 Kelvin you may write if you choose to do direct. Okay, so that is one thing. Now the next 8.5 question, this is also important. How much heat is required to increase the temperature of to increase the temperature of zero point 0.5 kilogram of water? So here the mass is 0.5 kilogram, as you see, of water from 10 degrees centigrade. Here T1 is 10 degrees centigrade to 65 degrees centigrade. Here T2 is required, and they ask what is the energy. So again, very simple, that Q is equal to, or delta Q equal mc delta T. Remember that I told you that you must remember the specific heat of water by heart. Usually it is not given. Why? Because it is very common in you, so much universal. But here I will write for you only once. And this C for water is 4200 joule per kilogram per Kelvin. Okay, so it is this. Now the next one is that here, sorry, the delta T also I want to tell you. This delta T will be the difference of these two temperature, and of course will this delta T will be equal to what? One sorry, uh, 55 kilo, right? Now the next question is about the an electric heater supplies heat at the rate of 1000 joule per second. Remember, so if you remember, that is nothing but it is the power, right? And you know the power formula. That power formula is work done, yeah, energy change per unit time, right? So this power is given to you. Okay, that is 1000 joules per second. So they ask you further that how much time is required. So here they ask about this time T, that how much time is required to raise the temperature of 200 gram. So the mass of the water is given, and it is 0.2 kg, because you need to change as per unit consistency checking. From this is your T1, right? And this is your what? T2. Clear? So this they ask delta T. Because they not ask, but we will need it. And of course I told you the quickest way, 20 minus 90 and 90 minus 20, 70, and this is of course 70 Kelvin. Now, as you know that, look, they ask about, as I told you about the time power is given. So what is time? Time is definitely equals delta Q by delta T, right? This is by delta T. Okay, so you just use this and solve the equation. And you know this is what? This is mc delta T, and sorry, this will become power divided by the power is 1000 joule per second. So you have the m, you have the c. Already I told for water c is this value, and you will get the answer in a second. So this is rather a very beautiful question. Now let us move on to the numerical 8.7. Here they ask you that how much ice will melt by 50,000 joule of energy. So here Q is given, or delta Q, the amount of heat energy is given to you of heat, the latent heat of fusion. So here the latent heat of fusion. heat of fusion is also given, and they ask you about the mass of the water. So as you know that Q for the that is the energy required for this is mass into the latent heat of fusion. So of course mass will come out to be Q into this latent heat of fusion. So this is very easy. And the 8.8 question, this is they tell you that find the quantity of the heat needed to melt 100 gram of ice. So mass of the ice m is 100 gram at minus 10 degrees centigrade into water at 0 degrees centigrade, right? Not the specific heat of ice. So the specific heat of ice, C for ice, is given, and the specific heat of water is also given, specific heat of water, and the latent heat of fusion of ice, the latent heat of fusion of ice is also given. So this question is a bit lengthy and I would prefer to solve it here. Look, this is that is the multi-dimensional numerical problem, a kind of challenging one. Here, you just see, look, first of all, the ice is at which temperature? From minus 10 degrees centigrade into water at 10 degrees centigrade. So the first the temperature of the ice be raised to what? The temperature be raised to 0 degrees centigrade, because the water can only melt at 0 degrees centigrade. Then second, this, that is first the temperature be raised to, for this the energy required will be Q1. The energy required, the energy required be Q1. Okay, then the second part, then in the second part it should be what? That is, it should be melt, right? That is melting of ice. Energy consumed are required in melting of the ice, and melting of the ice, and of course you know that it is the latent heat of fusion, and that will be Q2, it will be required. And in the third part, that is the amount of, that is raising the temperature of the water, then raising the temperature of water, the temperature of water from 0 degrees centigrade to 100 degrees centigrade. The energy required will be energy required. The energy required will be, it will be Q3. So total energy requirement, total energy, the total energy Q will be the sum of these three, Q1 plus Q2 plus Q3. So now if you see, look here, what I will be doing, this Q1 will be equal to what? M, right? Mass of the ice. C, the specific heat of the ice, for ice, into delta T. Into what? Into delta T. Here the delta T will be what? Here the delta T will be, look, your T1 is what? Your T1 is minus 10 degrees centigrade, and your T2 is 0 degrees centigrade. So of course T1, T2 minus T1 will be equal 10 Kelvin, right? It will be what? It will be 10 Kelvin. For example, how? Look, 0 minus and minus 10. So it is 10 degrees centigrade. And when you change it into Kelvin, so 0 plus 10 degrees, and so it will be, oh no. First you needed to change into Kelvin, then this into Kelvin, and then the difference, and it will be 10 Kelvin, right? So look, why? Because there is a minus sign, remember, so it will change it into plus. This one, the next one, this Q2, it is nothing but it is the mass of the water. Mass of the water and mass of the ice is the same as per the law of conservation of mass. Right, M into C. This time it is a water. It has changed into water now, and you want to change it into what? The ice, you want to change it into what? Into the energy consumed in melting the ice. Oh my god, this will be Q2, the latent heat of M into what? Into the latent heat of fusion of ice. Okay, now here the energy consumed is in melting the ice, not raising its temperature. And Q3, very simple, M C of water into delta T. Here, what is your this delta T? This delta T, here you have what? T1 0 degree centigrade, and your T2, you start to boil the water. 100, no, not to boil the water. Sorry, to raise its temperature to 10 degrees centigrade again. So what is this delta T? This delta T will be equal to what? It will be equal to 10 Kelvin again. This will be 10 Kelvin. Okay. It is you are not taking not boiling it. Okay, so that is for this. So what is the total energy? Now the total energy Q will be equal into what? Lock this MCI delta T plus MHF delta T plus MCW delta T. And let me make you a very new formula for you also. Take M common, and when such question comes, then do it like this: H heat of fusion plus CW delta T. Not to confuse this, let me make this delta T dash so that you should not confuse it in the formula. Okay, so you will get the answer and then inform me about your answer. Hope inshallah you will do it quite right. The next one is, how much heat energy is required to change mass of the water is given. This is M and it is 0.1 kilogram in of water at 100 degrees centigrade T1 into steam. The latent heat of vaporization of water is this one. So this is the heat of vaporization, right? And this Q definitely equal M into the heat of vaporization. As is yes, eating chocolates. So this is easy. Find the temperature of the water after passing 5 gram of steam at 100 degrees centigrade through 500 gram of water at 10 degrees centigrade. So here it is the mass of the water. Okay, and it is 0.5 kg. And here it, that is this of it find the temperature of the water after passing 5 gram of water. Here the temperature of the water is required, the T1 temperature is given. Okay, now you are passing the steam, so definitely you need to calculate the energy from the steam, right? But let me do it with a different pen. See here, you need to do this energy from the steam, and this energy from the steam can be calculated by using what? This, by using the delta Q energy. It will be just this one, M into the latent heat of fusion of water, which is already given there in the question above, right? This is the same like this. Okay, so here you will get what? And this mass is 0.005 kg. Okay, the mass here is this one. Once you get this energy, then it is very easy. You know that what is delta Q? Yeah, simple Q, you may write M C into delta t. So what is your, this implies that your delta t equals what? It is equal to delta q divided by mc, right? Now once you get the delta t, then what will happen for the delta t? You already know that delta t is equal to what? T2 minus t1 here. So this is your t1. So what will be your t2? Delta t plus t. Now you remember one important thing here, it is in centigrade, you need to change it into Kelvin, so your answer will be in the Kelvin rather than in degree centigrade, but in the book it is in degree centigrade. So what you will do, change back into the degree centigrade, right? They all the values and everything they have given. Oh, there is space, better I should solve it here. Okay, so this is your exercise for the solution to your exercise, right? And hope you might have learned a lot from them. Okay, you, so if you feel any difficulty or any problem, then you can contact me. Thank you very much for the today lecture, for attending the today lecture. This is all for now, and inshallah see you in the next lecture. Thank you very much.